This is lesson 9.4, and today our focus will be simplifying and multiplying rational expressions. We want to remember that a rational expression is nothing more than a fraction. So when we reduce a fraction, at this point you would look at, for example, 14 over 35, and you'd know that, oh, I can divide both by 7, and you would reduce it then to 2/5. But let's really look at what's going on. When you reduce a fraction, what you're doing is breaking it into what's called the prime factorization. In other words, you're factoring the number 14 into what multiplies together to make 14. 2 times 7. And then you're doing the same thing for 35. You're making it 5 times 7. And without realizing it, then what you're doing is canceling out what's common in both the numerator and the denominator, because those will divide and cancel to 1, which gives you the fraction 2/5. The same thing will happen down here with the second example. What you're doing is breaking it into its prime factorization. We can break 18 into 2 times 9, and then 9 breaks down into 3 times 3. And even though there's an x there, I'll still write it. And then the prime factorization for the numerator, or for the denominator, would be 3 times 7 times x. And what's happening here when we reduce this fraction, what we're doing is canceling what's common in both the numerator and the denominator. And then whatever's left over, 2 times 3 makes 6 in the numerator, and on the bottom we have 7x. So this is how we're going to break down our fractions. We're going to break them into a prime factorization. We're going to factor them and cancel then anything that's on the numerator and in the denominator. So let's take a look at this first expression. It's already been factored, it's already broken down. When we start looking at expressions that have polynomials in them with x's and x squareds, the most important thing we need to remember is that when we have an x minus 1, we need to remember that addition or subtraction always acts like a magnet. They're stuck together. X and 1. Up here we have x minus 3. Those are stuck together. You cannot separate them. So if I tried to go and try to cancel out this x and this x, I can't do that. That's a big no-no. I'm not going to cancel those out because they are stuck together with the 1 and with the 3. In order to cancel two sets of parentheses, they need to be identical, exactly the same. X minus 1 will only cancel with another x minus 1. And since all of our parentheses are different, none of them are going to cancel. And as a matter of fact, the only thing that we can cancel here is this x with the single x down here, because x squared is just another way to write x times x. So what we're going to have here is the x on top canceling with one of the x's on the bottom. So the only thing we can do to simplify this first expression is to cancel those x's. And so then what we have left is this. And that's all we can do for this one, because those terms are stuck together with addition or subtraction. Let's take a look at this example. A common mistake that people want to do is they see a 2x here and a 2x here, and they say, oh, I want to cancel those out. But remember, the bottom 2x plus 1, or the bottom 2x, is attached with a magnet with that addition sign to that 1. So you cannot cancel any. Sorry if there's a little glitch there. Let me say it again. You cannot cancel anything. They are stuck together. So now let's take a look at an expression that has not been factored. The first thing we're going to want to do every single time is to factor first. That is the very first thing. So let's go ahead and factor. In the numerator, I'm going to factor this trinomial into x minus 6 and x plus 2. If you struggle with factoring, I want you to go back and watch my previous video, which is a factoring review. I'm going to factor pretty fast in this video because I'm going to assume that you're okay with that. If you're not, go back and watch the other video. But for now, this will factor into these two parentheses. And once it's factored, then it's really easy to see. I have an x plus 2 in the top and an x plus 2 in the bottom. And so my final answer here is whatever's left over, not crossed out. This expression simplifies to x minus 6. So now let's take a look at this expression. I'm going to factor, And this time I'll be able to factor both the numerator and the denominator. The numerator is a difference of squares. I'm going to factor into x plus 2, x minus 2. And the bottom, the denominator, I'm going to factor this into x minus 4 and x plus 2. And now I'm going to cancel anything that's common in both the numerator and the denominator. I have an x plus 2 and an x plus 2, and then whatever I have left is my answer. So in the numerator, I have x minus 2 left, and on the bottom in the denominator I have x minus 4. And that's my final answer. And just a little word, sometimes people see the two x's here and they say, oh, I want to cancel those. No, you cannot cancel those two x's at all. You have to leave it as x minus 2 and x minus 4 because those x's are attached like a magnet with those terms 2 and 4. So now let's talk about multiplying. When we multiply fractions, we want to remember that we multiply straight across. So for example, I'm going to multiply 6 times 3x squared, and I'm going to get 18x squared. And on the bottom, I'll have 4x. We always multiply straight across. Then what we want to do is simplify anything that needs to be simplified. Both of these terms I can divide by 2, and I'll get 9 over 2. And then here I have an x squared. Well, this x squared is going to cancel with this x on the bottom. And I'm actually going to be left with just one x in the numerator. And my final result will be 9x over 2. So again, we just multiply straight across and then simplify. So here, what I'll do is multiply straight across. 3 times 9 is 27. X times x is x squared. Y squared times y squared is y to the 4th. And then in the denominator, I'll have 81 x to the 4th, y to the 5th. And at this point, I can then begin to simplify. I can actually divide both numbers by 27 and reduce this expression to 1 over 3. And then when I cancel out some of my variables, I'll remember my exponent rules that say subtract. So 4 minus 2 gives me an x squared, and I'll put it on the bottom because that's where my biggest exponent was. And then for my y's, 5 minus 4 gives me 1y left. So this expression simplifies to 1 over 3x squared times y. So now let's see how this works when we have some expressions that need to be factored first. As always, we're going to factor everything first, and we might have up to 4 things to factor in a given problem. So let's see what this looks like when I factor. I'm going to want to look for things like greatest common factors. So for example, in the numerator of the first fraction, I can factor out a 4x, which leaves me with x minus 1. The denominator is a trinomial, so I'll factor it as x plus 3, x minus 1. This numerator is a trinomial, so I'll factor it as x plus 3, x minus 2. And then the denominator is just 4x. I'm going to leave it like that. Now I know when I multiply, I'm just going to go straight across, and what's going to happen is this is going to turn into one great big fraction. So now what I'm going to do is I'm actually just going to look and see what can I cancel. Here's an x minus 1 and an x minus 1. I have an x plus 3 and an x plus 3. Oh look, I have a 4 and a 4 and an x and an x. The only thing that I have left is x minus 2. That's what this whole great big expression will simplify to. And as one last example, let's see what it looks like when I don't have a fraction for one of my expressions. Again, I'm going to factor first. And when I do, x minus 3 will just stay the same. But then this bottom, this is a difference of cubes. And we want to remember that difference of cubes formula. So here's your difference of cubes formula that we're going to use to factor this bottom expression. I'm going to use x as a and 3 as my b. And when I do, I'll have x minus 3 times x squared plus 3x plus 9. And then when I multiply with this expression, this will not factor at all. I can try and try, but it'll never happen. So what I'm going to do is I'm going to write it as a fraction. I'm going to put it over 1. And when I do, when I look at what I have in the denominator of my first fraction, I will see that, hey, this is going to cancel. This whole entire expression will cancel out. And as a matter of fact, so will my x minus 3's. And so when I have nothing left, my answer is 1. So again, this great big mess here simplifies down to one. Pretty cool.
Made with Doodlecast Pro.